So hi and welcome to another DCG tutorial. This question is from the 2012 paper. It is section A, question A2, so short question. So the 3D graphic below shows a road sign and its supporting frame. The supporting frame is in the form of a regular tetrahedron. The drawing on the right shows the plan and incomplete elevation of the structure. So here we have our 3D graphic. So basically it's a road sign, three-legged road sign in the form of a regular tetrahedron. You have the elevation and the plan, and you must complete the elevation. So part A, complete the elevation, include the directional arrow, and B, determine the true shape of the parallelogram shaped road sign. Okay, so first things first, the plan is completed, and they're giving you a lot of help here where they're bringing up a lot of the projection lines for you already. So let's project everything up to the elevation and then work off that. So they've brought up the corners here to show you that's your diagonal line across. So we need to finish off the road sign here. So that point here is going to be, as you see, on the ground. So if we bring that straight up, it's going to give us a point on the ground there. We need to bring up all 4 points of the arrow. So I need to bring all of those up. And also the back leg here is brought up for you already, so you can draw that in. So that's the back leg we're drawing back up to the top point. Now let's mark in a few of our points that we have on the drawing. So by base point here, that's going to be one of your points. Thanks to what they've done there, that is the corner here, the corner there. So the straight section of the arrow is going to be from here to this point here. Okay, after that then, the 2 points here. So you see these, the angle of the arrow is parallel to the angle of the edge of the sign. So what we're going to do is from that point, go parallel to the angle here, up, and then parallel to the angle down here. Figure that out. So we'll draw them in. So this is the outline of the arrow sign, and if I use that angle now and project it onto my point of the arrow here, I'll find that point. And if I do the same with the angle of the top part of the sign here, because they're parallel, so therefore they're going to remain parallel here, I'll find the top point. So that is this point here, following up, and that's it there. So complete the elevation. That is the sign done, that's the arrow put in, and that's the back leg. So that can be drawn in strong now. Okay, so that's the elevation finished. So we have the road sign put in and also the directional arrow. So that's part A done. Part B, determine the true shape of the parallelogram shaped road sign. So we need the true shape of this surface here. So in order to do that, we need to get height. So we can project down our length from the plan here, but we need height. So what we're going to do is get an edge view of that surface of the tetrahedron, an edge view of this line, to get the true length, the true height of that surface. So we're going to do an auxiliary view. So project that surface up here to the left. And we need to copy that angle. You need to project up the parallelogram. So that's the bottom point. We need the midpoint, and we need the top point. Put in an x1, y1, close enough here so don't run out of room. So what we're doing now is going to get an edge view of that surface, okay, it includes the parallelogram. So the base point is here. That's the base point here. The height of that point is going to be the vertical height here, because that's going to be the true distance from the ground to that point. So we get the distance from here to that height there. So that's this point here. Mark that up. That gives me the next point. Now if I join those together, now I'm getting an edge view of that entire surface, and now I'm getting the height, true height, for that part of the parallelogram as it crosses here. So what I'm going to do now is rotate everything down to the left hand side here, to the x1, y1. So rotate that around. Now I might have to extend my x1, y1. Bring this height down as well. So we're bringing everything down this direction. What you do is project those back to the same angle that you did your auxiliary view. So this was my angle. Okay, so project them back down. Now the true shape is found by extending out that center point. So we have the two base points already. Let's extend out that center point. And that's the center, that's the top point here. That was the top point there, so that's it there. We join that to the edges here, we get the true shape of the surface parallelogram is sitting on. And then these 2 points here are the two edges, the height of it, and then the bottom point there will be the base point of it. So the true shape of it, we draw that in strong now. Okay, so that is the question done. Part A, you did the elevation. Part B, the true shape of the parallelogram was found by just doing an auxiliary view of that edge of the surface it's sat on. Then you can project up the height of it to figure out the middle section there, and then that was your parallelogram. So hope that helped. If it did, leave a like, and if you'd like to see certain questions done, let me know in the comment section below. Okay, thank you and good luck.